All right, this video is for calculus. Obviously, I am not here because the baby is. So we're going to, instead of kind of walking you through this, I'm going to talk you through it on video. Not ideal, but it is what it is. So, Curious George is reaching for a banana at the top of a 150-foot tree, but he slips on a banana peel and begins to fall. Wah! So he's going to form this nice parabola here. So what we're going to have here is the tree. Got the roots coming out, branches coming out, and here is George right here. And when he falls, he's going to his graph actually is going to make this nice parabola. Okay, that's where this comes in. This is acceleration. This is half of acceleration due to gravity in feet per second. What is his starting velocity? Well, since he just fell and he wasn't thrown down, his starting velocity is going to be 0. His starting height is 150, so that's 150. And we're going to say h of t is equal to negative 16 t squared 0 times t. It's just going to, we don't need to worry about that, plus 150. So now what you need to do is use your use Desmos or your lightsaber, but make a graph for this. And the graph's going to look like that, of course. All right, so the question is, how long will it take George to hit the ground? Fortunately, it's covered with banana peels, so he's not going to actually die. If you don't remember his height when he hits the ground, well, his height is 0. But you could also just graph this on your graphing calculator and find the 0 that way. You could graph it in Desmos and find this point right here that way. I'm going to go ahead and solve it analytically here. So 0, when he hits the ground, is negative 16 t squared plus 150. So 16 t squared equals 150. 150 divided by 16, take the square root of this. Make old school calculator here. 150 divided by 16, and take the square root of that. And we'll get about 3.06 seconds. 3.061862. All right. Average velocity. Well, the average velocity, just like if I need to calculate the average speed, I'm going to calculate how fast the total change in distance over the total change in time. So average velocity would be the change in position, or the change in height, over the total change in time. So, well, that'd be 150. He fell 150 feet, divided by 3.061862 seconds. And let's see here. I'm going to take this number, and we're just going to invert it. Take it times 150, same as dividing. So his average speed was 48.98979. 48.98979 feet per second. Now that's his average velocity, but if we look at this graph here, okay, so that's his average velocity. But as we all know, when you actually hit the ground, you're going much faster right here than you were up here, okay? And this is where the whole tangent line problem comes in, okay? The slope here is his speed. What is his average velocity from 1 second after he falls until impact? Okay, well, I got to find his height at 1 second. I'm going to find the change in height over the change in time again. So in this case, his height at 1 second until he hits, which was his height at 3.061862 seconds. All right, so after 1 second, now if I plug in 1 here, that's going to be 150 minus 16. It's going to be 134 feet minus, well, the height when he hit was 0. And we're going to get negative 2.061862 seconds. So 134 divided by 2.061862. And so, well, from 1 second till he hit the ground, that was 64.9898 feet per second. And of course, this one was negative because he's going down, and this is negative because he's going down. What about 2 seconds until impact? Okay. I'm going to let you go ahead and do 2 seconds till impact and 2.5 seconds till impact, and then we'll see what happens. We'll see how you do from there.